Okay, the second standard that we're looking at is C.1.2, find limits by substitution. Any continuous function that doesn't have any weird breaks or asymptotes or anything like that happening in it, the limits can usually be found just by a simple substitution. So, for example, find the limit as x approaches 5 of 2x plus 1. So, we want to know what's happening with the function 2x plus 1 when x gets really, really close to 5 from the left and the right side, as it gets to 4.9, 4.99, and also as it gets to 5.1 and 5.01. So remember, we got to also keep in mind that the limit is what's happening from, so like if this is just a very rushed approximation of the graph right here, let's say this is x equals 5. We want to know what's happening as you proceed on the function values this way and this way. All right, so a limit is, these are usually called a two-sided limit, and because we're going to look at one-sided limits a little bit later on. Okay, so we want to know this function's good and continuous all the way through. The domain is all real numbers, so we can just simply substitute to find out the y value, or f of x, what this is, and that is going to be what the function is actually approaching there. So we can simply just say 2 times 5 plus 1, which is 11. So we would say that the limit as x approaches 5 of 2x plus 1 is 11. And sure enough, if we go to a graph and look at that and plot a table, so if we put in 4.9, we should get we should get 9.98 plus 1, which is 10.98. So, so that is when x is 4.9. When x is 5.1, we get 10.2 plus 1, 10.0, 10.202. I don't know. Yeah, because it should be 11.02. So we see that as it gets really close to 5, the function values get really, really close to 11. This holds true for any continuous function. Let's see if x approaches 2 of x cubed minus 3x squared plus 11. We know that's a continuous function, so we can just substitute. So 2 cubed minus 3 times 2 squared plus 11. That gives us 8 minus 12, which is negative 4, plus 11, which is 7. So this function will be approaching 7 as x gets really, really, really close to 2. All right. The same holds true for trig functions. So as the limit approaches x, the limit as x approaches, let's say pi of sine of x. So we plug in, we substitute pi. So the sine of pi is 0. So the graph, or the values, the f of x, the y values of sine, as x gets really, really close to pi, will get really, really close to 0. And the limit as x approaches 1 of e to the x is just e, which is approximately 2.718. Okay, and so most of the time substitution is just fine. However, going off of the function from the first example that we put up here, x squared plus 2x minus 8, all divided by x minus 2. When we substitute 2 we get, it doesn't really matter what we get in the numerator, because in the bottom, so we get 4, 4, so this one's the, so talk about two things at once here. When you have the denominator as 0, the function is not continuous there, but it can still have a limit. And we know that it can still have a limit there if we get this form, which is called the indeterminate form. So whenever you obtain 0 divided by 0 from a substitution and a limit, you know that the limit can still exist because that's an indeterminate form. We can't determine whether or not something's going on there. All we know from that is that it's not continuous there. However, the behavior of the function suggested, as we looked in the graph before, that from the left and the right they were both approaching the value of 6. So the limit is indeed of this one, even though we didn't find it with substitution, the limit is 6. And the limit exists, even though the function's not continuous there. And we will learn how to handle that in another presentation. Just to show you an example, I'll make one up here. The limit as x approaches 2 of x plus 3 divided by x minus 2. So when we substitute 2, we end up getting 5 divided by 0. So something divided by 0 doesn't exist. But we also know that the limit doesn't exist there because what's going to happen there, that's going to be an asymptote. And so easy way to kind of categorize it for yourself. When you get nothing divided by nothing, 0 divided by 0, that's the indeterminate form, and you could still possibly have a limit there. If you get something divided by 0, then that's going to be an asymptote, and the limit does not exist. So kind of a way to categorize it, and that is it for finding limits by substitution. So that's leading us into our next slides.